5-4, solving compound inequalities and. Essential question, how do you solve a compound inequality that is written in interval form? So today is another day of and, but the problems are going to look a little bit differently than the first day of and. Solve and graph. So this looks like one big long inequality. We're still going to start solving it the way we would as if there were only one inequality instead of two. I'm going to draw double train tracks. And then I'm trying to get r all by itself. So the way I do that is by subtracting 7. But instead of just doing it twice, I'm going to do it over here on the left also. So 7 and negative 7 make 0, so I'm left with r here. 6 minus 7 is negative 1. 10 minus 7 is 3. Now the way we break this up into two inequalities is I'm going to need my 3 number lines again, so I'm going to make 2 more here. All right. Oops, I have to move this line back down. Okay. So this one is my first inequality. But we know that if we want to use our graphing trick, the r has to be on the left. So I'm going to rewrite it. My alligator mouth is eating the r, so my alligator mouth has to eat the r. R is greater than or equal to negative 1. That's my first inequality. My second inequality is r is less than or equal to 3. So that's going to go on my second number line. And then my third number line is going to be the and of these two inequalities. So I need my number lines to go from negative 1 to 3. Okay, so r is greater than or equal to negative 1. Close circle on negative 1, and my arrow is pointing to the right, showing the shade to the right. Middle one, r is less than or equal to 3, so close circle on 3, shaded to the left. For my third graph, I'm going to start by making my 2 dots. One dot was on negative 1, one was on 3. Now I have to look at what numbers are shaded on both number lines. Now if this helps you to visually see, I can move this one down and this one down. And where do my lines overlap? In between negative 1 and 3. So now if I bring these back up, I know I have to shade in between negative 1 and 3. This type of graph is an interval. That's all we're going to have today. When your problem starts out like this, you need to automatically know it's and you have to automatically know it's going to be an interval every time. Every time. So an interval looks like that third graph, shaded in between. So numbers that are greater than or equal to negative 1 and less than or equal to 3 are negative 1, 0, 1, 2, and 3. Same thing again, double train tracks. I'm trying to get x by itself, so I'm going to add 3 in the middle, on the right, and on the left. Negative 2 plus 3 is 1. 4 plus 3 is 7. Now, make a couple more number lines here. Okay, so this is my first inequality. Now I want to rewrite it so x is on the left. My alligator mouth is eating x. So that one's ready to go. X is greater than or equal to negative 1. Excuse me, positive 1. Then my second inequality is right here. X is less than or equal to 7. So I need my number lines to go from 1 to 7. Okay. So the top one is closed circle on 1, shaded to the right. The middle one is closed circle on 7, shaded to the left. So I have to make my closed circle on 1 on my third number line, my closed circle on 7. So now I have to ask myself, what numbers are shaded on the top number line and the middle number line? Well, 1, 2, 3, 4, 5, 6, 7. I can't go any smaller than 1 because there's nothing here. I can't go any bigger than 7 because there's nothing there. So I'm going to shade in between. Interval graphs go with the word and, which is what we're dealing with today. And an interval graph, an interval problem should create an interval graph, which it did. Train tracks. This time my couple isn't just a variable, it's 2x. So let's still subtract 1 on both sides. 9 minus 1 is 8. Now I have to break up my couple, so divide everything by 2. So we have 2 is less than or equal to x, which is less than 4. So now if I create 2 more number lines for this, let's move all these up so we have a little more space. Okay, first number line is x is greater than or equal to 2. Middle number line is x is less than 4. All right, so we need our number lines to go from 2 to 4. So close circle on 2, shaded to the right. Open circle on 4, shaded to the left. Closed on 2, open on 4. Numbers that are shaded on both are 2 and 3. 4 isn't shaded on both, it's only shaded on the top one, so that's why it's an open circle. It's not shaded there, it's open, it doesn't include that point. Write an inequality for the graph. Well, first of all, we know we have an interval. So we know our problem is going to look similar to what these ones looked like. So let's see, we have a closed circle on -1 and an open circle on 2. So I'm going to put my -1 on the left, my 2 on the right, with my variable in the middle. Now let's see. If I'm trying to figure out which way my inequalities go, well, I have a closed circle on -1 shaded to the right. So that means x has to be greater than or equal to -1. If you get confused about which way the inequality symbol should go, I'm shading to the right, so that means x is bigger, so I need my alligator mouth to open up to the x. Now with my 2, it's an open circle and I'm shaded to the left. So that means x is less than 2. This one had a closed circle. This one had an open circle. So that's how I know that 1 is or equal to and 1 is not. All right, let's try the next one. This time we've got our circles on -3 and +4. I'll put my x in the middle. So this one, my x values are greater than x, or greater than -3, so my alligator mouth needs to be open to the x. No line underneath because it's an open circle. My x values are less than 4, so less than 4, and then I need a line underneath it because it's a closed circle. So -3 is less than x, which is less than or equal to 4. Write an inequality and graph. The range of acceptable scores on the test is 70% to 100%. So the smaller of my acceptable scores is 70. The bigger of my acceptable scores is 100. Now I'm not going to count what all those lines should be in the middle, but we'll just roughly say that that's right. So it's the acceptable scores are 70 to 100, so that includes 70. 70 is acceptable, 100 is acceptable, so that means we would shade in between. Anything in between 70 and 100, and including 70 and 100 is considered acceptable. So you can get 70 on the test, 75, 80, 85, 90, 95, all the way to 100, and that's considered acceptable. Most snakes live where the temperatures are between 75 and 90 degrees. So let's put 75 here, maybe I'll count by fives on this one, 80, 85, 90. Between 75 and 90 degrees. So we have to think about, does that include 75 and 90? Let's look back at the wording on the last problem. The range of acceptable scores on the test is 70 to 100. That included those. When you see the word between, that means it doesn't include 75 and 90. It's in between 75 and 90. So I would just shade in between with open circles. Open circle at 75, open circle at 90. Now I'm looking back and they also want us to write an inequality, which I didn't do. So let's put our 70 here, 100 here, X here, and you'll notice the pattern. It always ends up being less than symbols. So that's kind of our pattern for intervals. It's always a less than. Sometimes it's less than or equal to, sometimes it's not. This one was closed circle, so I needed the or equal to. Same thing here for this one, 75 here, 90 here, X in the middle. It's always less than symbols, and we don't have a closed circle, so it is just less than, not less than, or equal to. Summary. The homework for this lesson is pages 306 through 307, numbers 4, 10 through 11, 16, 18 through 19, 39, 44, and 46 through 49.